Hello future teachers. In this video I will discuss the properties of logarithms. Let's start with the definition of logarithm. The logarithm of a number to a given base is the exponent to which the base must be raised in order to produce that number. That's quite a mouthful, but to understand this definition all you really need to know is that y equals log base b to the x is equivalent to b raised to the power y equals x. For example, the logarithm of 1,000 to base 10 is 3 because 10 to the third power is 1,000. An important fact that comes from this definition is that y equals log to the base b to x and y equals b to the x are inverses. This will be a useful tool for graphing logarithmic functions. It is useful to learn the basic properties with respect to common logarithms, which are logarithms with base 10. For example, y equals log base 10 of 1 is 0 because 10 to the 0 is 1. Using the same process, we find that log base 10 of 10 is 1, log base 10 of 100 is equal to log base 10 of 10 squared, which is equal to 2, and log base 10 of 1,000 is equal to 3, and so on. Here's a summary of the properties we just went over using any base b. Now that we have set the basic foundation for logarithms, there are some basic properties that are useful when solving log problems. The first one is that log base b of x times y is equal to log base b of x plus log base b of y. We tested this property by graphing two functions on Geometer's Sketchpad, y equals log of x times x, or log of x squared, and y equals log of x plus log of x. As you can see, the graphs are equivalent and thus the property holds. Similarly, log base b of x divided by y is equal to log base b of x minus log base b of y. We can again use common logs to test our last property. Log base b of x raised to the nth power is equal to n times log base b of x. For example, log base 10 of 10 to the fourth is equal to 4 times log base 10 of 10, which equals 4. This property is especially helpful when predicting the logs of large numbers. For example, let's look to find the log base 10 of 54,712 by using the properties we just went over. First, change into scientific notation to get log base 10 of 5.4712 times 10 to the fourth. From our property involving multiplication of logs, this is equivalent to log base 10 of 5.4712 plus log base 10 of 10 to the fourth. Next, we can bring the power of 4 to the front to get log base 10 of 5.4712 plus 4 times log base 10 of 10, which is equal to log base 10 of 5.4712 plus 4, because log base 10 of 10 is 1. Last but not least, we know that log base 10 of 5.4712 is between 0 and 1, because 5.4712 is between 1 and 10, and log base 10 of 1 equals 0, and log base 10 of 10 is equal to 1. Thus, log base 10 of 54,712 is between 4 and 5.
Next, we will go into graphing techniques for logarithms. Let's graph log base 3 of the cubed root of x. One of the main properties of logarithms is that log base b of x and b to the x are inverses. To simplify this problem, let's just focus on log base 3 of x. We know that the inverse of log base 3 of x is 3 to the x, which is a much easier equation to graph. If you are unsure of what the graph of 3 to the x looks like, just start plugging in points. For example, when x equals 0, y equals 3 to the 0, which equals 1. Plot the point 0, 1. Continuing this process, we calculate that other coordinates are 1, 3, 2, 9, and negative 1, 1/3. We can plot these points and then connect these points to approximate the graph of y equals 3 to the x. After watching the videos in the inverse function section, we know that to graph an inverse, you reflect about the line y equals x. So we construct this line and reflect the graph y equals 3 to the x over it. This gives us the graph of log base 3 of x. Based on the properties of logs that we went over earlier, we know that f of x equals log base 3 of cubed root of x is equal to log base 3 of x to the 1/3, which equals 1/3 times log base 3 of x. The relationship between 1/3 log base 3 of x and log base 3 of x is that for every x value, the y value of 1/3 log base 3 of x is 1/3 the y value of log base 3 of x. To test this, we can pick an arbitrary point on the graph of y equals log base 3 of x, call it A, and measure its coordinates, which as you can see are 10, 2.1. Then multiply the y value by 1/3 and use the same x value and plot that point, which would be 10, 0.7. We can repeat this process to find a couple more coordinate pairs, which are shown here. Connect these points to approximate the graph of y equals log base 3 of the cubed root of x. If you would like to try a similar problem on your own, go to the extra problem section.